Today, I thought I would try something a little more refreshing than cabbage juice. And this lemon lime soft drink sure does hit the spot. And guess what? Your teacher will have a soft drink for you too today. But first, well, you knew there would be a catch. We all have to learn a little bit about reacting acids and bases.
In this lesson, you will define neutralization reaction, write an equation for a neutralization reaction, describe titration, define endpoint, and determine the molarity of an acid or base using titration data.
Let's begin by writing the equation for the reaction between hydrochloric acid and sodium hydroxide. Since the name of the acid is hydrochloric acid, we know that it is a combination of hydrogen and chlorine. Hydrogen forms positive 1 ions and chlorine forms negative 1 ions, so the formula is simply HCl. To write the formula for sodium hydroxide, we need to use the periodic table to remember that sodium has a positive 1 charge. We can also use our charge chart to see that hydroxide is the polyatomic ion OH with a negative 1 charge. So the formula is NaOH. We write these two formulas as our reactants. Look closely at this reaction and see if you can figure out how to classify it.
It looks like a double replacement reaction to me.
Exactly. We know that the ions switch partners in a double replacement reaction. So hydrogen joins with hydroxide and sodium joins with chlorine. Of course, a compound which contains 2 atoms of hydrogen and 1 atom of oxygen is simply water. So our reaction is HCl plus NaOH yields water plus NaCl. You will recall that NaCl is the formula for table salt. So our acid reacted with our base to form water and table salt. This is a pattern for all neutralization reactions.
A neutralization reaction is the reaction between an acid and a base to produce a salt plus water, where a salt is defined as a compound containing the cation from a base and the anion from an acid.
That sounds easy. If we react any acid with any base, we will get NaCl and water.
No, the salt formed in a neutralization reaction is not always table salt.
I was just testing you. And of course, you're exactly right. We are so used to thinking of salt as the stuff we sprinkle on our food that sometimes we have trouble with the notion of a salt being the compound formed from the reaction of any acid and base. I'm glad you got that one figured out. Now let's write a couple more reactions before we move on. Write the neutralization reaction when H2SO4 reacts with KOH. Label the acid, the base, and the salt.
All neutralization reactions are double displacement reactions, so the ions in our reactants need to switch partners. Potassium, which forms a positive 1 cation, joins with sulfate, which forms a negative 2 anion to make the compound K2SO4. Hydrogen joins with hydroxide to form water. So we have H2SO4 plus KOH yields K2SO4 plus water. H2SO4 is our acid, KOH is our base, and K2SO4 is our salt. Looking closely at this reaction, we see that it needs to be balanced. A coefficient of 2 in front of the KOH and a coefficient of 2 in front of the water will do the trick.
Don't you love it when the new thing we are learning is just a review of several things we have learned in the past? Writing neutralization reactions simply involves writing formulas, predicting products from a double replacement reaction, and balancing. All things you've mastered in the past. Here's one for you to try.
Write the neutralization reaction when nitric acid reacts with magnesium hydroxide. Local teachers, please pause the tape now for the students to work this problem.
You should have written 2HNO3 plus MgOH2 yields MgNO32 plus 2H2O. Don't worry, your local teacher has more for you to practice, beginning with a lab involving that soft drink that I promised you. Enjoy! Local teachers, please pause the tape now. Welcome back. I hope you enjoyed your lab. Now, we are going to look a little more closely at neutralization reactions by taking the concentration of the acid and base into account.
A titration is a laboratory method used to determine the concentration of an acid or base in solution by performing a neutralization reaction with a standard solution. In a neutral solution, the moles of hydrogen ions must equal the moles of hydroxide ions. To find the moles of hydrogen ions, you use the following formula. Moles of hydrogen ions per 1 mole of acid times the molarity of the acid times the volume of the acid. To find the moles of hydroxide ions, you use the following formula. Moles of hydroxide ions per 1 mole of base times the molarity of the base times the volume of the base. Since the moles of hydrogen ions equal the moles of hydroxide ions, the moles of hydrogen ions per 1 mole of acid times the molarity of the acid times the volume of the acid equals the moles of hydroxide ions per 1 mole of base times the molarity of the base times the volume of the base.
Right on cue. We're glad you're here, Mr. Mole. I'm just about to do a little experiment to help the students with this concept. Here's the problem we're going to solve by experimentation. Find the molarity of this sample of hydrochloric acid by neutralizing it with 0.5 molar sodium hydroxide. Well, I've carefully measured 50.0 milliliters of the hydrochloric acid and have poured it into this Erlenmeyer flask. It doesn't matter how much acid we start with, as long as we keep track of the numbers as we go. I chose 50.0 milliliters because it's a nice round number. Be sure to record 50.0 milliliters as the initial volume of hydrochloric acid in the data table on your note-taking guide. We then add a couple of drops of phenolphthalein to the acid. Thanks, Mr. Mole. Hey, nice safety goggles, by the way. What do you think the phenolphthalein is for?
The pH-TH will indicate when the neutralization is complete.
Precisely. Now, we're going to use an instrument called a burette to slowly deliver the sodium hydroxide into the hydrochloric acid. You can see that the burette's markings will make it easy for us to determine how much sodium hydroxide is used in the neutralization process. We add sodium hydroxide almost to the top of the burette. And then we let out the solution until the reading is 0.0 milliliters. Whatever the reading is when the reaction is completed will be the volume of base we've added. Now, we turn the valve to slowly release the sodium hydroxide into the hydrochloric acid. You can see that the phenolphthalein in the acid detects the base when it is added. We swirl the flask to evenly distribute the base. We will continue to add sodium hydroxide until the faint pink color begins to stay for longer periods of time. At this point, we add the sodium hydroxide drop by drop, so we don't add too much. When the faint pink color remains after about 30 seconds of swirling, we have reached the end point of the titration.
The end point of a titration is the point at which the indicator changes color. This color change shows that neutralization has been reached. At this endpoint, the moles of hydrogen ions and the moles of hydroxide ions are equal.
Now that we have reached the end point, we record the volume of sodium hydroxide, which is 20.2 milliliters.
At the end point of the titration, the moles of hydrogen ions equal the moles of hydroxide ions. So we use the formula, the moles of hydrogen ions per 1 mole of acid times the molarity of the acid times the volume of the acid equals the moles of hydroxide ions per 1 mole of base times the molarity of the base times the volume of the base. The formula for hydrochloric acid is HCl, so there is 1 mole of hydrogen ions for every 1 mole of acid. The volume of acid used is 50.0 milliliters, and the molarity of the acid is what we're looking for. The formula for sodium hydroxide is NaOH, so there is 1 mole of hydroxide ions for every 1 mole of base. The molarity of the base is 0.5 molar. The volume of the base that was used is 20.2 milliliters. We multiply 1 times 0.5 times 20.2 to get 10.1, and then divide by 50.0 to get 0.2 molar hydrochloric acid.
So, we were able to find the molarity of the acid given the molarity of the base. That is a titration. What do you think, Mr. Mole? I agree. Mr. Mole thinks that this is one of those types of problems that you need to try for yourself to see if you get it. Try this one. In a titration of HCl with KOH, 50.0 milliliters of the base were required to neutralize 10.0 milliliters of 3.0 molar HCl. What is the molarity of the KOH?
Local teachers, please pause the tape for your students to work this problem.
Let's see how you did. You needed to use the formula that says the moles of hydrogen ions per 1 mole of acid times the molarity of the acid times the volume of the acid equals the moles of hydroxide ions per 1 mole of base times the molarity of the base times the volume of the base. You have 1 mole of hydrogen ions for every mole of acid, 3.0 molar acid, and 10.0 milliliters of acid. You have 1 mole of hydroxide ions for every mole of base, an unknown molarity of base, and 50.0 milliliters of base. Multiply 3.0 times 10.0 and then divide by 50.0 to get the molarity of the base to be 0.6 molar. This should be starting to click. Mr. Mole wants you to try one more problem. 60.0 milliliters of 0.50 molar NaOH were required to neutralize 30.0 milliliters of H2SO4. What is the molarity of the acid?
Local teachers, please pause the tape for your students to work this problem.
Did you get it? Let's check your work. Again, you use the formula the moles of hydrogen ions per 1 mole of acid times the molarity of the acid times the volume of the acid equals the moles of hydroxide ions per 1 mole of base times the molarity of the base times the volume of the base. In this case, there are 2 moles of hydrogen ions for every mole of acid. The molarity of the acid is unknown, and the volume of the acid is 30.0 milliliters. There is 1 mole of hydroxide ions for every mole of base. The base is 0.50 molar, and 60.0 milliliters of base was used. Multiply 0.50 times 60.0, and then divide by 2 times 30.0 to get the concentration of the acid to be 0.50 molar. As always, your local teacher has more of these for you to practice. Let's turn now to the chemistry quiz.
Cumulative review question number 1. Which of the following is not a characteristic of a base? A. Turns acid-base indicators different colors. B. Feels slippery to the touch. C. Tastes sour. D. Is an electrolyte. Cumulative review question number 2. Which of the following would occur in an acidic solution? A. Blue litmus paper would turn red. B. Red litmus paper would turn blue. C. Phenolphthalein would turn hot pink. D. Cabbage juice would turn green. Question number 1 for today. The products of a neutralization reaction are always A. An acid and a base. B. An acid and water. C. A base and water. D. A salt and water. Question number 2 is true or false. Table salt is always produced when an acid reacts with a base. A. True. B. False. Number 3. The laboratory method used to determine the concentration of an acid or base in solution by performing a neutralization reaction with a standard solution is called A. Neutralization, B. Salination, C. Titration, D. Acid-base experimentation. Number 4. When a titration is complete, what 2 things are equal? A. The volume of acid and the volume of base. B. The moles of acid and the moles of base. C. The volume of hydrogen ions and the volume of hydroxide ions. D. The moles of hydrogen ions and the moles of hydroxide ions. You'll need your math hat for number 5. If 25.0 milliliters of 0.50 molar NaOH are used to titrate 45.0 milliliters of HCl, what is the molarity of the acid? A. 0.28 molar. B. 0.90 molar. C. 0.56 molar. D. 0.14 molar.
Well, that's finished, and so is this lesson. I'll see you next time, and we'll study reaction rates. Okay, Mr. Mole, on your mark, get set, go!